All right, here we go. A ball is thrown from a wet tunnel. It's pushing it upwards. The acceleration of the ball can be described as 4.0 t minus 10. Assume that negative 10 is the acceleration of gravity. The ball is thrown with initial velocity negative 30 meters per second. The top of the tunnel is 250 meters above the ground level. What is equated for the velocity of the ball while it is in flight? So I have an acceleration formula. Not Mr. Sauce, because he's not here. Mr. Rock. Oh, not Mr. Rock. He knows how to do. Mr. Prowl. He knows how to do calculus? No.
Yeah, that's bold of you to assume.
No.
CSGO.
All right, so how do I get to velocity?
So the reverse of the power rule.
Reverse of the power rule. Raise its power. What do I do? Raise power or lower its power?
You do the one where you take the power, add 1 to it, and divide A by that.
Okay. Raise its power by 1, divide by the power I get. Raise its power by 1, divide by the power I get. And as a special warning, we need a constant. We need an initial velocity. Right? Whenever we integrate, whenever we go this way, we're going to, for rate to an amount, we have to worry about initial velocity or quantity. Okay, so that's the equation, except what's the initial velocity?
Negative 30 meters per second.
Negative 30 meters per second. So continue this problem. I go 2 t squared minus 10t. That blinking is probably a problem. Okay, minus 30. Okay. What's the instantaneous velocity 3 seconds into the flight?
Awesome.
What do I do? Well, I have its velocity for any time. All I have to do now is plug in a 3.
You just plug in a 3 for the t. Right.
Mm-hmm. 60, 50, 42. I'm getting negative 42 meters per second. Check me, that doesn't feel right. Somebody check me.
That's what I
All right. Well, you agree that I'm probably right in spite of myself. Okay. Now how to get to displacement?
You do the same thing again with the velocity equation.
Same thing to the velocity equation. Gets me to displacement. So displacement equation is going to be, I'm going to go y of t. It's going to be equal to raise its power by 1 divided by the power I get. Raise its power by 1 divided by the power I get. Raise its power by 1 divided by the power I get. And I need an initial height.
250, which is plus 250.
So we'll write 250 in there. This is plus 250. Yep. Okay. And then the last question is going to be, what's the displacement 5 seconds after it's been thrown?
Plug in 5.
Just plug in a 5 everywhere. Uh, 83.3. Yep. Yep. And then minus, this is negative 275. So minus 25. So something like 58.3. Mr. Sauce, you still with us?
Yeah, I got that.
Okay. Make sense, sort of?
Yeah.
All right. Now we get to practice this so we get it cold. And how I'm going to practice to get it cold, I have a ridiculous worksheet full of problems to do. Have at it.